Thank you very much. This is a collaborative work with Evgeny Germanov and Anton Fedorenko. You probably know them perfectly. Well, many thanks for invitation, of course. It's a great challenge for us and a great honor. The talk is regarding this so-called informational side, and of course, how to measure it using electrochemistry. When we start, to talk about this informational side, many people, ask, okay, what it is, and how we can, of course, measure this. But before starting this, I would like really to show that whatever is behind this phenomena related to information, there is a long history. You know, all this old, in Sumerian civilization, Egypt, they use this, it's of course a very different terminology and very different terms, but they use all these phenomena what we know now. I really like this example, this Metternich stela. It's about 2,500 years ago. And the idea is when a person is poisoned or bitten by animal, though that people should put water on the stone. And when water is going through all of this symbol, that receive this information properties, it properly should be some, some activities from these people. It should be collected here, and the people should drink it. And at least the text said that people become somehow protected. Whatever it's written 2,000 years ago, we use a very similar approach as now. This I will not really go deeply in this slide, but almost everybody knows this. There's a lot of different techniques. We probably call today this entanglement, and a different notion of this. But they start to use from the beginning of this written history, and this use even now. Without any changes. Probably most interesting to start, from this industrial revolution, from Renaissance time, where people start to think in more scientific way, start to try to understand and to describe different scientific phenomena. In those time, there was magnetism, a great discovery. When people tried to explain all these phenomena, all of these effects, just in this magnetic way. Great name, I don't need to say anything here. Just, mainly what we know now and what we use was discovered by Reichenbach. In the change of this the 20th century, technology changed to electromagnetic understanding, to radio. There was a great, again, discovery in technology and society. And the people start to think about all of this information phenomena just in the way of electromagnetic emission, of radio. And we see, again, a lot of great discoveries, for instance, from Korshel, from Lachovsky. And it's amazing that all these devices are produced even today, and they are in use even today. Again, a change, a technological change. People change the terminology from radio emission to energy. It's again, we encounter for this Hieronymus, it's a well-known name as well. The change understanding of this phenomena from electromagnetic to energy, and this term, there was alloptic, electric and optic energy. And there's a great experiment that's replicated, I don't know how many times. There was even today running replication of this experiment, just running some plants without sunlight, taking this energy and putting it in the downstairs. It's a great experiment. Reich, of course, there's a long, ongoing, controversial discussion. Even today in the journals like Science and Water Journal, there's a great article from James. It's still in discussion. And there's a Russian work in 80s and 90s. You see there's a lot of technologies coming in, and again, change the understanding of this phenomena. Now people think in terms of fields. They think about quantum phenomena, think about physical vacuum. But the usage of these devices is more or less the same like before. For instance, this was used for this long-term entanglement experiments. So you see that each time when change technology, the changing understanding of these things. This is the next step, informational age. and now it's again technology. So we use this a kind of information. We extract information. We change this information. We transfer information through wires. Store this again, and many people in this room use this approach in different forms. And now we call this more or less information and use with the information. Well, the question is, of course, you see that 6,000 years people use more or less the same phenomena. They call them differently. They give different explanation, but the phenomena itself still remains the same. I mean, this great thing we should always remember that the 6,000 years, this doesn't change, and it's a little bit amazing. I mean, many things they gone, but they still remain. We try to more or less to realize what is a model of this, how we can work with this model, and can we really treat this phenomena like information phenomena? I mean, just understanding example. So there's a computer, there's a lot of hardware, there's a lot of software. Software treats with data, and data are collected in internet. And the internet is a beautiful thing. We don't care about hardware anymore. We just say, well, there is some hardware, but nobody really knows what is TCP/IP. Where is this cloud server? I mean, we have a cloud, but where is the server? I mean, we don't care about this. So we treat now this information like abstracted information. Well, now, of course, we see analogy. When we have this, for instance, with water, this information carrier, and then we could probably say, well, we can treat this a kind of separated information. The question is, of course, can we do this? There is enough proof for handling this phenomena like independent phenomena, try to really to subtract and handle like in abstracted way. Well, this is a difficult question. Of course, there's a lot of discussion in different communities. In our work, we try to approach this from the viewpoint of electrochemistry, but a little bit more in details, because this is a quite important point. We know there's a physical or chemical system, and we know we can measure a lot of parameters here. One of them, for instance, using optical spectroscopy or using impedance spectroscopy or measuring pH or different approaches. And the point is this effect, what we call this information or informational effect, they appear not always. The system should be treated. We say, well, in many cases, when we just expose this by this weak emission or non-electromagnetic emission, or there was many times said about human consciousness or that human operator somehow focus on the system, so we encounter appearance of this information part here. The question is, when we really consider this, then we can assume that there is a lot of similar system existing in the around, and there is a lot of interaction between our information system and neighbor information system. And of course, we can probably somehow find this and record this interaction and to see them in this electrochemistry measurement. And so the system will behave in unusual way. So it's the first way how we can, for instance, detect it. The second way is very interesting. We can put a local impact on the system as a fluid. We can put light, we can heat it, but we can do it non-locally. I mean, we can, for instance, put this impact or the system impacting this informational part on 1 kilometer, 100 kilometer, 10,000 kilometer, and observe what will happen. And of course, when we do this in very large distance, then of course the question is probably we are no longer interacting with this part, we're really interacting with this part. I would like to be absolutely clear at this point. This is a water conference. I mean, we, of course, performing water research, but there is a large number of phenomena, also this kind of phenomena, but they are not related to water. I mean, there's a very different system. For instance, this passive geometric structure, I will tell a little bit more about this. It's just a couple of geometric shapes. There's LED generators they use in very different system. There's entropy changes when we're dissolving some salt, that they behave in similar way. So when pumping water through coils or light in the coils, that's very similar phenomena. So in general, here we observe it can be very different systems. So all of them indicated similar phenomena. Well, now when we use with electrochemistry shortly, what kind of equipment and what kind of methodology do we use? First, we use impedance spectroscopy. We have in laboratory standard equipment. Was quite unsatisfied, and we developed our own. It's currently on the market. So it's a differential. There's 2 channels. In total, it record about 29 data channels. All these environmental parameters, temperature, magnetic field, electric field. So, the good thing in impedance spectroscopy, when you know a model of the system or of this fluid, you can identify parameters measured from, for instance, from the device. You can put in the model, and you can more or less really go in understanding what is happening. How different impact, for instance, consciousness impact or technical impact, how they differ from each other. So I will show a few examples where this impact it can be really differentiated from each other. Another is, I reported this last conference, is a potentiometry. It's the same, we use a standard equipment, but not really satisfied with this, so develop it own. We are able to measure here, it's more or less really on the boundary of this sensitivity of electrode, about let's say 10 of microvolt. It's in relation to pH, it's 10 of power minus 6 pH, so it's more or less a theoretical resolution. We put, of course, in the thermostabilization container this protection from electric field, protection from all possible environmental impacts, and again record all these environmental parameters. So we can identify if this impact is coming from, let's say, non-local source or from local source. Again, whatever we do, it's everything published. These are old equipment. It's a DC conductometry. It's create extremely deeply polarized electrodes, and the sensing element is double electric layer here. It's a great sensitivity, but extremely unstable. But we still use it sometimes. And last is a high frequency conductometry. In this case, it's water, also conductivity of water is measured inside of closed ampulle. So there is no chemical interaction in this it's fully encapsulated system, and we use both inductive and capacitive cells for this. Well, this is more or less for equipment what we used for this for impedance spectroscopy. Very important to say is stabilization from temperature and all environmental parameters. So you see, for instance, here is for 12 days or more or less 2 weeks. And this temperature stabilization for electronic system and for samples. So it's very important that we really stabilize it and record all these parameters. Well, now let's think about this interaction. How these interactions, the information interaction between, let's say, informational part, whatever it is, from our system and the number, how it can be. What we observed, it basically was told us by our colleagues who worked in this field before us, when performing these weak measurements, the noise in the system dramatically increased. And basically there is no reason for this. I mean, why the system should increase? The noise in the system should increase. We know, for instance, from Kolmogorov complexity, when the noise is increasing, the system increases the degrees of freedom and becomes more complex. And when the system is closed, why this should become more complex? The idea is probably through this information interaction with environment. See, for instance, here is a differential impedance. So first today, it's more or less noise at the low level. It's important. We performed experiments here. So the system is under this weak emission. So, and then after this, we receive a lot of high-frequency noise, and they start with low-frequency noise, and after this, we cannot perform any measurement anymore. I mean, it's really the system breakdown. It's not only with impedance. Here is the same as the potentiometry in the simplest form. So we have 2 bimetal electrodes we put in just in the fluid. And you see here is, of course, a potential degrade with time, so we observe this degradation. But please take a look at the level of noise. This signal is after 1 day of experiment, so we observe here again a lot of low frequency noise. And 120 hours later, we receive also modulation by low frequency signals. So it seems that the system receives more and more interaction, more and more degrees of freedom, and we see this as increased noise. Another example, again with noise, in this case, there is high-frequency conductometry. So it's, like I said, there's a fully encapsulated fluid here in the ampulle. We performed experiment. There was a human operator. We just measuring this impact of operator. And you see here, also, just in the level of noise, after each experiment, level of noise dramatically increase. So like in previous cases, first high-frequency components, and then we receive a kind of low-frequency modulation of this. This is really amazing. Important to say that it's not only fluidic phenomena demonstrate this effect. I just put 2 slides from different systems to demonstrate that the increasing of noise has a kind of universal nature. Here is this passive generator, this passive geometric structure, and here we measure just potential. I mean, this electric field is, of course, modulated by 50 hertz, and we measure here potential by a voltmeter. And we measuring a frequency. It's important we measuring a frequency here. It's, for instance, over the long time, we measuring is just in this position away from this generator. And you see that, I mean, there's really 50 hertz. There's a small deviations, small noise, but everything is fine. Now, we shifted this probe to one of these generators, and we have a human operator working with the system, and we see first appearance of the spikes, and after a while, operator is still working with this, we observe appearance of a noise. I mean, and again, it's a frequency of 50 hertz. I mean, it's a phenomenon extremely unusual. I mean, we fail to reproduce it with any other system. I mean, 50 hertz is extremely stable system itself. Well, not only noise disappear. For instance, here there is the impedance spectroscopy as a phase, as a capacitive part. And there is a control channel, and there is no emission applied to this channel. But to the second channel, this red one, there is emission applied. And you see after 3 days appear a periodical oscillation. I mean, in the system, closed system, there is no interaction. It is fully closed. We observe periodical oscillation with period of 12 hours. We could probably say it's specific to the system, probably some technical artifact. There's another example. Here, we're measuring pH. Setup is the same. So here is a control channel. There's no emission applied. There's no experiment. Experiment is performed with this channel. And after a couple of hours after applying, you see here appearance of periodical oscillation in pH. As oscillation is small, it's really something like 10 of -5. But still, I mean, oscillation is period between 6 and 8 hours. I mean, in pH, and only in the experimental channel. Another beautiful example. This is more or less our pH system. So 2 channels that are separated from each other, and this inside of this container, this measuring fluid. Here we're measuring the pH here. And here, after below this channel, we put samples, and this one sample is a control sample, as not treated. This blue one is from, probably somebody knows it, from Brazzo. It's quite a famous Croatian guy. And we perform measurement for him, and then we put this like here, and then at this point we switch on UV light in the laboratory, and pH inside of this channel that demonstrated jump. Again, jump is small. It's something like 10 of -4 pH, but nevertheless, I mean, what is the reason to have the jump here, just inside of the closed system? But nevertheless, we observe this. It's not only one experiment. I mean, in many cases, we're starting to observe here, for instance, it's again pH. There is no exposition, and here we expose samples. And here in the night, there is some correlation. We assume there's a kind of astronomic event, probably moon or something else. I mean, it's always difficult to say what it was. But nevertheless, I mean, the systems start to behave quite strange, in a strange way. I mean, this is more or less what is related to information interaction. But when we put this non-electromagnetic or high penetrating emission, there are different names for this. This generator, one example is a fully passive. There is no electromagnetic emission. I mean, there is really there was a couple of geometric shapes. We put a sample just in the front of this device. And the exposition time is varies between, it depends, 30 minutes up to 2 weeks. Well, and then after this we perform impedance spectroscopy. It's very interesting what is happening here. Here is the curves before exposition. You see that the system is electrochemically stable. We perform 10 measurements, and there is no difference in this measurement. Really equal. I mean, the whole system behaves like a normal system, what we expect to have. But please take a look after exposition. So when we perform again these 10 measurements, especially in low frequency area, the system is no longer electrochemically stable. I mean, whatever measurement we perform, the second measurement will differ. Here we rest it for a while and perform again measurement, and you see we again receive different impedance from the system. So it's more or less, that was already told several times that the system after experiment is no longer stable. This is exactly the case. Well, we put, of course, a different impact. This is one of impact what we tested from our colleagues. Semedicals, this well-known magnetic bracelet. So again, we expose this, and this is 0 hours, and perform, I mean, the lot of measurement is Nyquist exposed, this impedance data. And you see this immediately after experiment and 24 hours later, we receive different values. We measured it 72 hours later. It's again different. So the system is no longer stable. So it changed the behavior. Very interesting in this case, experimenting with colloidal fluids. The colloidals in general is very tough because they are perceived not stable. So whatever you measuring, for instance, before experiment, they are not stable. But when exposing to emission, first of all, it's beautiful because you can see visually a difference. So difference, for instance, exposed from not exposed. And after explosion, the system becomes stable. I mean, they really change electrochemical behavior, in this case, wires, that it becomes stable in the high frequency area. So, there are only a few examples how this system, when it starts interacting with some environmental system, that it's happening, it's not really in this way, this interaction are happening here. But more interesting is, of course, when we start to increase this impacting distance. Okay, well, what does it mean is increasing impacting distance? This is one of these very first experiments that's performed in Russia in 86. Well, there was in Moscow. Here there was a receiver and emitter, but it's not really a receiver and emitter. This is a kind of what we assume a quantum phenomena, so that's it's not something really emitting. It was a device that created this entanglement. This is a signal just in the receiver, in the sender side, this on the receiver side. I mean, distance 22 kilometers. After this, there was performed a huge number of experiments in that way. So it's, for instance, system from our colleagues from Semedicals. That's here in the Europe, the service center. There's a lot of clients over the whole world. So it's a non-locally. Our experiment, what we performed in our group, the receiver was in Stuttgart, and this part was creating this entanglement in Australia, in Perth. So distance is about 13,750 kilometers, as estimated by Google Maps. And for instance, here is the electrochemical behavior after the impact. So you see extremely clear response of the system. Just somebody in over the half of the world switched small device. I mean, this powering is about 1 milliwatt. It's like this pointer, and we 10,000 kilometers away. We receive it. We receive it. Well, up to now, at least in our community, over 900 experiments is performed. The statistic is huge. It's published many times. And what we're a little bit worried, it's not really that people is attracted attention of people. Whatever we cannot explain, we just ignore this. And we exactly observe this behavior. We cannot explain, okay, we ignore this. Well, then we decided let's do it, something different now. Okay, we know technology work, we have devices, equipment for this. Let's do something else. And the idea is, well, let's do it first of all extremely public. We put everything open, all these devices, all technology, everything is open. It's open science. And here we can create from many points in the world this entanglement links. And here we have a feedback, and for instance, we can put a feedback to any particular point. Okay, how does it look? This is one of the setup in laboratory. In our laboratory, there's impedance spectrometer. There are in these boxes, measurement boxes here. There's a webcam, so we can have feedback. This important plot all this data on internet, so everybody immediately see in real-time response. And I have this entanglement key with me, and I was pretty much surprised when I just entered here in the conference. At the beginning of conference, we receive a kind of response of the system. Just in the beginning, exactly it was something like between 9 and 10 o'clock. Wow. And the interesting is only one channel, exactly that the key used in this moment demonstrated this change. Another channel that demonstrate anything. Well, to this public experiment, we created in a Facebook group. So it's a number of people that's actively joining to this experiment. We basically invite you, of course, to join to us. Well, we publicly discuss this creation of experiment, what kind of experiment should we perform, and the whole methodology is public now. And there's a few examples. With this new system, what we performed basically from the September. It's really a new system. We started in September. So it's in Stuttgart. There's a mental impact. You see the changing of impedance. It's a very clear response. The changing of phase as a capacitive part. So we start to think about how to separate different kind of this non-local impact, for instance, from consciousness, from devices, like I said. So this 3 kilometers in Stuttgart. This was in Bratislava last week. I have a talk, this for instance here, there's an impact, and you immediately see, a very different behavior after this impact, electrochemical behavior. Again, Carlo performed this demonstration. Yes, that was just here in this room. And when I saw, okay, it's a public demonstration, let's see, okay, what is happening? And of course, I'm skeptic. Then and say, okay, well, it will not happen. Okay, and then again I left. But after a while, next morning I discovered, oops, that was something. Okay, and then we approached Carlo and asking him for a separated experiment and separated room. And there was 3 of us for a control. And exactly at the time when Carlo started this experiment, and this morning we received reactions of system. Please think about the system, and the recording system is in Stuttgart. We have 1,200 kilometers. And it was, done as an excellent example. It's congratulations to Carlos. Well, I'm closing now. Like I said, we are extremely public in that way. So we publish methodology, result, whatever in the journal. I just using this opportunity to represent this our journal. It's more or less, let's say, new, but new about 4 years new, so it's quite old. So it's now available for international community. Please submit your paper. This popularity of journals is increasing very fast. So here again. We show that more or less in this electrochemical system here, we see this kind of information interaction. On this side, we measure this non-local impact, and we have real data. So now, of course, what we think, and European community basically force us, it's now a huge trend in EU to make innovation, to be innovative, to make from fundamental science some product. And just a few examples, this again from colleagues from IC. So it's a new informational medicine and informational pharmacology. Just think there's a first example of this informational pharmacology that was 2,500 years ago. It's a great history, I think. Well, what we use, and it's work pretty well in agriculture. So all these plants are extremely sensitive to this kind of impact. So it's a practical field experiments. And we have a lot of partners working on that. And what is really hot now is anti-aging. So you know, everybody would like to be young. So and there's well, again, this experiment they started from 60s. Now about 50 years of this anti-aging. In Russia, by the way, it's very popular now. So it's probably a good thing to go there. And of course, one example of metallurgy. So at least I can report many companies from Turkey, from Germany, they indicated interest to change properties. I mean, this in this way. So it's not informational pharmacology; it's informational metallurgy. So it's great. So to conclusion. First of all, what we demonstrate last time and this time again, we have a statistical significance. So we know, for instance, I mean, all the problem that repeatability is about 70 to 80%. But when using multiple instruments, for instance, we use 9 spectrometer or 9 conductivity measure devices, we receive a response in 100% of cases. I mean, now we can overstep this. Okay, this is well repeatable, and we're collecting a large statistical significance. So this weak emission or whatever, I mean, we assume it probably has a kind of quantum phenomena. It's more or less going to this, but it's affected by a large number of external factors. It's an astronomical event, whatever is happening in laboratory. The consciousness from operator is a great impact. I mean, there's a large number of results in that way. And what this informational site, I mean, I repeat it again, it's a very beautiful and very useful abstraction. I mean, first of all, it should be extremely clear here. But it seems that it's a little bit more than a useful abstraction, because there are many mechanisms that really interact with this informational side. And I should say there's open ethical issues, because, I mean, you know, we are now in the age of technology where we can easily modify biological system. Of course, biological systems, they have immunity to this kind, but this can be overstepped, so it's dangerous. So last, I mean, I put it intentionally that people really recognize there's a changing something in the world, and a well-known publisher approached us and asked, okay, he said wordly that now is the right time to start this. And well, it's a handbook. Well, title and discussion. I mean, it's biophysics. They would like to say psychotronics. Well, okay, it's in discussion. Nevertheless, it's about 30-35 chapters. Europe, US, Russia, China. I mean, there's different countries will be for sure devoted to information effect, non-local phenomena, agriculture, water, new energy, medicine, consciousness, macro quantum phenomena, sensor. I mean, please contribute. We will make call for this. Okay. Thank you very much.
Thank you very much, Sergey. I was just expecting you to show a real-time screen or link to your system back in Stuttgart, so how it would react to you being here presenting. Well, we have time for a few questions. Rumiana?
Thank you very much for your presentation. Lots of thoughts. Do you connect your channels with consciousness? And what is the relation between how your channels work and consciousness?
Well, it's a good question. It's really one of the greatest questions at all. You know, we follow some specific methodology of understanding this phenomena. This is more or less what was done in Russia in this unconventional field. And people, I mean, this methodology say, okay, no mystic behind this, whatever we can measure exists, whatever we cannot measure doesn't exist. So it's more or less methodology. I mean, connecting channel and consciousness, at least in this methodology, consciousness of a human has a similar nature like this generator. So we have a kind of generator of this emission inside of us, properly of quantum nature. Through our imagination, we can, for instance, make a kind of non-local link to something, and we can put intentionally, for instance, concentration, or by using some intention, we can modulate this emission. So we have a kind of analogy between technological device and, let's say, human operator. We also performed experimenting by combining them and for instance, increasing power or increasing something or decreasing values. So in this term, I mean, we don't really see a difference when we perform experiments with devices accessing our measurement sensors or with a human operator. But I mean, experiments are just the operator concentrate, sometimes use this non-local link, sometimes not. I mean, there's a different setup. But like I said, concentrated use.
Yep. Okay, if there's so many things that might influence your channel, so only the consciousness could explain the result that you show.
Well, I mean, as we are engineers, so engineers, we think more technological way. It's very simple to switch off operator when you just perform iterative, for instance, with exact period experiments. You switch on, switch off some device with exactly the same period. I mean, human intention probably can take the first iteration, second iteration, but after a while, after, for instance, 1 week, I mean, no operator can take it 1 week long, yeah? And when we perform iterative experiment 1 week long with exactly the same period, then it's true that's probably not a human intention. That's how we differentiate between human and non-human.
Okay, James, final question?
Yes, I wanted to mention in conjunction with the last question, the work of the great Russian thinker and cosmologist Khaznevsky, who I had the privilege of knowing and working with slightly in his long-distance mind over matter experiments showing that consciousness is a hidden variable. So we should look at his research both in German and Russian. I've published some of his papers, Intelligent Reflections on Planet Earth, showing that the human is a cosmic, planetary, ecological, anthropomorphic being working with multiple scales of information simultaneously.
Yeah, I mean, I fully agree with you, and I fully agree, of course, with Kozyrev. And before Kozyrev, there was many discussions. Probably we, as a human, we have this, let's call it informational side, whatever it is. And probably this creates our own informational ecology and ecosystem. And we have much more than just a biological being on the Earth. I fully agree with this.